We have a container that is connected to a vertical manometer open to the atmosphere. We are given the density, the height difference of the mercury in the column, the gravitational acceleration, and the atmospheric pressure. Part A is to determine the pressure exerted by the mercury column, and Part B is to determine the absolute pressure of the gas in the container. The pressure in the system pushes on the mercury from this end, while the atmospheric pressure pushes on this end. Here we can see that the mercury is higher on the atmospheric side, meaning that the pressure in the system is higher than the atmospheric pressure. And our height that we were given is relative to where the equilibrium point of the mercury is. We can draw this line here, which is known as the isobar, or the line of equal pressure. And this tells us the height, h, that we were given, which is 56.38 centimeters. The first thing I'm going to do in this problem is make sure that all the units are consistent. Our density was given to us as 13.534 grams per centimeter cubed. And we need to convert this into kilograms per meter. So we'll multiply by 1 kilogram is equal to 1,000 grams. Then we'll convert the centimeters to meters by multiplying by 100 centimeters for every 1 meter. And then since the centimeters are cubed, we need to cube this conversion factor. This gives us that the pressure is equal to 13,534 kilograms per meter cubed. Next, we need to put our height into meters. It was given as 56.38 centimeters. We need to convert to meters. We have 1 meter over 100 centimeters. This gives us our height as 0.5638 meters. Now that everything is in the right form, we can find our pressure exerted by the mercury column. So our pressure is equal to rho GH, which is our density times the gravitational constant times the height of the mercury. So solving this, we have our density as 13,534 kilograms per meter cubed times our gravitational constant of 9.832 meters per second squared, and then times our height of 0.5638 meters. This gives us our pressure of 75,022.38 kilograms per meter second squared. Now, kilograms per meter second squared is equivalent to newtons per meter squared, which is equivalent to pascals, which is important because our atmospheric pressure was given in kilopascals. So to convert this to kilopascals, we just need to divide this number by 1,000, giving us our pressure of 75.022 kilopascals. Now for part B, to determine the absolute pressure of the gas in our container, which is the same as the pressure of our system, that is equal to the gauge pressure plus the atmospheric pressure. And this pressure over here is our gauge pressure. So the pressure of our system is equivalent to our gauge pressure of 75.022 kilopascals plus our atmospheric pressure of 101.78 kilopascals. Solving this, the pressure of our system, or the absolute pressure, is equal to 176.802 kilopascals.